Hey everyone, and welcome. Today we're going to talk about something that's super important in the world of data, but, it often gets pushed to the side. We're talking about statistical dispersion. Think of it like the secret story that averages just can't tell you all by themselves.
So let me just ask you this straight up. When you see a number like, say, the average price of a house or the average temperature, do you really think that one number gives you the whole picture? I mean, is it really enough to tell the entire story?
All right, let's just jump right in with an example. Take a look at these two classes. You've got Class A with scores of 8, 9, and 10. Pretty consistent, right? They're all huddled together. But then you've got Class B. Scores are 1, 9, and 17. I mean, they're all over the place. Now here's the kicker. The average score for both classes is exactly the same. It's a 9. So if you only looked at that average, you'd think, hey, these classes performed the same. But you and I can see that's not true at all, right?
And boom, right there, that simple example shows the massive problem with just relying on averages. They give you the center, sure, but they tell you absolutely nothing about how consistent the data is or how spread out it is. That's the big data mystery we're going to crack today.
Yeah, think of it like this. The average is like a single dot on a map. It tells you the center of gravity for all your data, but it totally hides the real story. Are all the data points packed in tightly around that dot, or are they scattered for miles in every direction? To see that, well, we're going to need a whole different set of tools.
So how do we actually solve this thing? Well, the answer is something statisticians call measures of dispersion, or sometimes variability. Fancy words, I know, but all they really are the tools that let us measure that spread we keep talking about. Basically, these dispersion measures are designed for one job, to describe the scatter of your data around a central point, like the mean. And that word scatter is just perfect, isn't it? It's exactly what we saw with those classes. Class A, barely any scatter. Class B, man, it was scattered all over the place.
Okay, so how do we actually put a number on this scatter? Let's start with a couple of the simplest tools in our, let's call it our data detective kit. We're going to look at the range and the interquartile range.
The range is by far the easiest one to get. It's super simple. You just take the highest number in your data set, subtract the lowest number, and that's it. That's your range. It gives you a really quick back-of-the-napkin idea of the total spread of your data. But, its biggest strength, its simplicity, is also its biggest weakness. See, the range only looks at two numbers, the very highest and the very lowest. So what happens if you have one crazy high or low number, what we call an outlier? It can throw the whole thing off and give you a totally misleading picture. Imagine you're looking at house prices, and then suddenly someone builds a massive mansion. That one house is going to blow up the range and make it look like prices are way more spread out than they actually are for everyone else. So to fix that problem, we need something a little more robust. Enter the interquartile range, or IQR for short. It's a really smart way to just focus on the middle chunk of your data. So here's how it works. First, you line up all your data from smallest to biggest. Then you find the median, the dead center. After that, you find the median of the bottom half of the data, we call that Q1, and the median of the top half, that's Q3. And the IQR, it's just the distance between those two, Q3 minus Q1. So why is this so powerful? Well, the IQR is literally the range of the middle 50% of your data. It just completely chops off the bottom quarter and the top quarter of your data, which, hey, is exactly where those weirdo outliers tend to hang out. This is awesome for things like salary information. You can ignore the crazy high CEO salaries and get a much better picture of what the typical person in the company actually earns. Okay, but if we're looking for the heavyweight champion, the most common, most powerful tool for measuring spread, the real gold standard, then we have to talk about standard deviation. I'm sure you've heard this term thrown around, so let's actually figure out what it means.
At its heart, the standard deviation is just a way to measure the typical distance that any given data point is from the average. That's it. If you have a big standard deviation, it means your data is really spread out. Think of a stock price that's all over the map. And if you have a small one, it means all your data is bunched up really close together, like the super consistent scores of a pro athlete. Now here's a really key point. To understand standard deviation, you kind of have to know about its sibling, variance. Variance also measures spread, but it has this weird quirk. It gives you the answer in squared units. So if you're measuring dollars, your variance is in dollars squared. What even is a dollar squared? It's impossible to wrap your head around. And that's why standard deviation is so great. It just takes the square root of the variance, which puts the number back into the original units, back into plain old dollars.
So much easier to understand.
All right, enough with the theory. Theory's great, but let's see how this stuff actually works in the real world. We're going to take our tools and solve a little data puzzle using some real scores from a stats exam. Okay, so here's our data. We've got the scores for 10 different students, and you can see right away they're kind of all over the place. The lowest score is a 4, the highest is a 20, and there's a bunch in the middle. Just for context, the average score for this class is 11. First up, let's use our simplest tool, the range. Easy peasy. Highest score is 20, lowest is 4. Subtract them, and you get a range of 16. That tells us the total distance between the best and worst scores.
Okay, next, let's look at the variance. If you crunch the numbers, you get about 31.8. But again, what does that mean? 31.8 squared scores? It just doesn't make any sense in the real world, which is exactly why we have that next step. And here it is, the standard deviation. It comes out to about 5.6. Now this is a number we can actually use. It's back in the right units, just regular old exam points. So what this tells us is that a typical student in this class scored about 5.6 points away, either higher or lower from that class average of 11. And that right there is really the main point of this whole thing. The average, it just gives you one spot. It's a location. And that's useful, but it's only one piece of the puzzle. It's the measures of dispersion, things like the standard deviation, that tell you the rest of the story. They give you the context, the consistency, the whole shape of the data. You know, one of our sources said it perfectly. The standard deviation indicates how much the distribution of values scatters around the mean value. That's it. It's the number that tells you about the scatter. So I'm going to leave you with a question. The next time you're reading an article or watching the news and you hear someone use the word average to prove a point, I hope the first thing that pops into your head is, okay, but what's the spread?